Mr. Tadhg Dornan!
Hi, I'm Tadhg and I'm a geologist. For everyone sitting in the front row who's probably like, why the hell is there a hammer on the front of the stage? It's just for scale, so that's fine. That joke was told intentionally to make all of the geologists in the room laugh. Alright, so basically when people find out that you're a geologist, the first thing that they tend to do is dive straight into all of the puns. The most common of which is where they stare you right in the eye and then they go, oh, you study geology. Does it rock? And it's not that it's bad or that we don't like it. It's just that it makes the rocks really unhappy and then go to seek vengeance. So when you start doing geology, you get given this special rock, and when somebody says around you basically says a really terrible geology pun, then that rock sends signals out to all of the surrounding rocks, telling you basically to hunt you down. So has everyone here heard of the theory of continental drift? It's basically where all the land masses around the Earth either move closer to each other or further away due to things that's happening below ground. Yeah, well, that's just a massive cover-up. What's actually happening is the rocks are really ever and so slowly getting an assault on all of you terrible people. Additionally, if you ever beat a geologist in the game of rock, paper, scissors with rock, you get this power and then you win at geology. Alright, so if I'm being really, really honest, those were just trying to take up time. The real topic of my conversation. So I had a really, really hard time thinking of an actual topic of conversation for this talk. So, Stephen, do you want to come up? Yeah, so I did what all good scientists would do when they're stuck thinking of things to do, and I asked my mum. Alright, so I got my mum to sit down at our kitchen table and I said to her, okay, mum, write down any questions that you have about geology. And fair play to her, she got 8 questions. She started at 9th, but obviously there's only so much geology you can take. My intentions was at the very start to do jokes about each one, but doing jokes about all 8 proved really, really difficult. So I'm just going to pick and choose which one to do. All right. So I'm going to start with question number 4, and it's what's the difference between rocks and minerals? So first of all, that's a really good question, ma'am. The short answer is that rocks are made up of minerals. So if you get lots and lots of minerals added into a group and put them together, it makes a rock. So for instance, there's one mineral called amphibole, and if one individual amphibole groups together with another amphibole, and they group together with more and more amphiboles, then you get an amphibolite. Easy. Right, but the problem is that not all minerals within rocks are the same size. So to describe how this works, I'm going to talk about a substance that's really analogous to rocks, ice cream, and in particular cookie dough ice cream. So cookie dough ice cream is mainly made up of vanilla ice cream with big chunks of cookie dough. Right, so if you were to describe them in geological terms, the ice cream is really, really tiny, tiny crystals that you can't see with your own eye. So we would call them fine grained. All right. While if you have the big chunks of cookie dough, you can see them with your eye, and you call them coarse grained. But for some reason, with cookie dough ice cream, even though it's made mostly of vanilla ice cream and with only small intermittent chunks of cookie dough, it's still called cookie dough ice cream. Strangely enough, this still works in geology. So if we had to take our amphibolite that we were talking about earlier and we added in a really delicious garnet, it becomes a garnet amphibolite because like ice cream, rocks are named after their most delicious component. Now, I do realise that I jumped straight to question 4, but question number 1 was made completely null and void after a recent trip with my geology class. It is, how do you accurately date rocks? So when we were talking about how to answer this question, it descended into us making an app for how the rocks find their true love. And it was called Boulder. But, instead of male or female, you have igneous, sedimentary, or metamorphic. And then instead of age ranges, you have actual geological time. Now, this sounds really far-fetched, but when you realize that geologists describe rocks using terms like cleavage, thrust, and dike, it's actually not that, it's actually not that bad. All right, so that must have taken up a good bit of time. So I'm going to jump straight to the bottom. And the 8th question is, since pyrite can cause cracks and damage in houses, does it do the same in nature? Now, there's 3 people here at the front who are staring at me going, what the fuck? It's as if my mum was sitting at a kitchen table and just had this instant wave of geological inspiration hit her all at once. But it actually sets me up pretty nicely to talk about my research. So what I do is I look at the mineral pyrite, and in particular I look at pyrite in your houses. So what I look at in general is that the way your houses were built was somebody dug a big hole and then filled that hole with rocks and then put a concrete slab on top of the rocks, and then your house was built on top of that. But if there's pyrite in those rocks and that pyrite gets wet, because there's iron in it, it tends to oxidize. And that oxidization sets off this big reaction chain, and the rocks start to swell, and that concrete slab starts to rise up and crack. Right? It sounds really bad. But the way my mum phrased it was as if like pyrite only does that in like captivity. It's like wild pyrite acts completely normal. But just in houses, it just goes completely and utterly berserk. But yeah, that was pretty much it. But that led me on to another topic of like, when you do like a PhD or a master's or even a degree, it sets you back to like doing the Leaving Cert again. People ask you the same 2 questions. The first of which is, so how's it going? And that gets pretty old after a while. You kind of have to like make up an answer that you just give to everybody, and everyone's like, oh, that's good. The second of which is, so what are you going to do when you finish? And that's a really good question. Fortunately for me, and unfortunately for the people whose houses got really badly damaged, this problem's going to go on for a while, so I'm going to be studying this for another while. But because it's going to be such a long-running problem, and it's actually such a problem here, we're looking at it in other countries. And there's scope to look at it in countries like Bermuda and the Bahamas. I know, yeah, tough gig. But the real reason, and yeah, the project is going to be called Pyrites of the Caribbean. And with that terrible pun. So I started with puns and I'm going to end with a pun. Thank you very much. That was me.
Tadhg Dornan, everybody!